Okay, good afternoon class. So at this point we are looking at the cycle test 2. What's happening here now? The one that you guys wrote the other day. Okay, so we started off with question 1. We are asked to refer to the table below and answer the questions that follow. Okay. Calculate the correlation coefficient for the data above. So for the correlation coefficient, we need to program our calculator. Okay. So we press setup, mode, 3 for stat, 2 for A plus Bx. Okay. So the values are 10 in the X row, it's 10, then 16. Can somebody read out the values? 11, 12, 32, 24, 21, 19. Is that it? Then the Y column, the Y row, 17, 35, we press equal, yes? 20, 23, 83, 59, 50, 44. Then we press AC, that we can store our data. We press shift 1, 5 for regression, 3 for correlation coefficient, your R value. And you'll see that your R value is a perfect 1. Okay. Let's go to 1.2. What can be deduced from your answer in question 1.1? Firstly, it's going to be positive. Perfect correlation. Not so. So positive perfect correlation. Use your calculator to determine the equation for the least square, your regression line, or your line of best fit, or it could be called your least squares regression line. It's all the same. In the form of y is equal to a plus bx, so we go y is equal to. Now we already punch this information into the calculator. Again, you press shift 1, 5 for regression, 1 for a, gives you negative 13, and I think it was positive 3 if I'm not mistaken. Press shift 1, 5 for regression, 2 for b. Whoops. Five for regression, 2 for b. The answer is 3. So that's your equation of your least squares regression line. Let's look at number 4. Number 4 says, give a positive value for x where it might not be a wise decision to predict the value for y using the line of best fit. Explain your answer. So here, firstly, it must be a positive value, so the value must be greater than 0. Not so. So if you chose any value between, what's the lowest value here, people? I think it's 11. 10. So anything between 0 and 10, as long as x is greater than 0 but less than 10, or the learner has written a value, what's the largest x value? 32. Any value greater than 32, that was acceptable. Okay. As long as the value is between 0 and 10 or larger than 32. Okay. Then you should get the mark there. Why? Because it's outside your data range or your data's domain. Can you see that, people? So it's outside the data set. Outside the data set. Okay, with the data's domain or range. Okay. People, that's how you get 7 marks. For some of you didn't get 7. That's how you get 7. Okay. Now it is find the equation, find the general solution of the equation. So the general solution, what do we need? We need to simplify this here first. Okay. People, we know that tan is what? So it's sine A over cos of A is equal to. Now sine 2A can be written as what? 2 sine A cos A. Now multiply out, multiply with the cos A as well. So it's going to be sine A equals 2 times 2 is 4 over 3. Sine A cos A times cos A is going to be cos squared A. Not so? You get over the equal sign, so 0. People, you don't divide by sine of A. You will be losing a solution. So it's 4 over 3 sine A cos squared A minus sine A. We take out sine A as a common factor. I'm left with 4 over 3 cos squared A minus 1. We said each one equal to 0, so sine of A is equal to 0, or 4 over 3 cos squared A minus 1 is equal to 0. We take the 1 over, divide both sides by 4 over 3, and then get cos squared A is equal to 4 over 3. Now we take the 1 over, so it's 3 over 4. Is that correct? Yeah, 3 over 4. If I take the square root here, what must I not forget? Plus minus. So cos of A is equal to plus minus the square root of 3 over 4. Or the root of 3 over 2. Okay. People, now we've got the positive and negative solution. Which means to say, if it's positive, it's in quadrant 1 and 4, and if it's negative, it's quadrant 2 and 3. They haven't omitted anything yet. So we must represent it in all 4 quadrants. Okay? So let's do that quickly. So we know my reference angle. Reference A is equal to r cos of root 3 over 2. I get 30 degrees. Is that correct? Check. It should be 30. Because I sine of A is equal to half, which then give me 30 as well. So yes, that one is correct. So in all 4 quadrants, in quadrant 1, it's going to be A is equal to 30 plus K times 360. Quadrant 2, A is equal to 180 minus 30, which is 150, plus K times 360. Quadrant 3, I know this is an easier way to write it, but let's just say A is equal to plus minus 30, because then you're counting for quadrant 1 and 4, plus K times 360. And for quadrant 2 and the 2 and 3, you're going to just say A is equal to plus minus 150 plus K times 360. But we don't really work with positive angles, so we have a positive, negative angle, sorry. So we normally convert it to positive. Okay? So that's all stations to clear one. Quadrant 1, quadrant 2. Are we getting to quadrant 3? It's going to be 180 plus 30, which is 210 plus K times 360. And quadrant 4, A is equal to 360 minus 30, which is 330 plus K times 360, where K is an element of integers. And on the other side, remember, if that is 1 minus 1 is 0, I take it to the graph. Where sine equal to 0? At 0 and at 180 and 360, of course. So here we can just say x is equal to 0 plus K times 360, or x equal to 0 plus K times 360, or we can write it as 1. Since the solution is happening every 180 degrees, x is equal to 0 plus K times 180, or just K 180. Give you the same solution. Okay? And that, saying that is it's applicable for both branches of your equation, or both solutions of the equation. Okay? People, let's carry on. In 2.2, in the diagram below, semicircle the center A. People, if this is a semicircle, then the length of AF is equal to AE, and FC is equal to AB. FC is equal to AB. Why? Because of a radius there, or radii, and many things, no? The semicircle with center A. Diameter FAE going through B and C lies on a horizontal plane. We are told that CB is 9, then the angle CAB is 110 degrees. We are then told that AD is a vertical pole. People, if that's a vertical pole, then that is 1990. Okay? The one is vertical and your horizontal. Okay? Your vertical pole to the plane and it's 2 meters in height. First question. We are told calculate the length. I'll make this a bit smaller. Okay, the question says calculate the length of BD. Now you answer to 4 decimal places. BD. So BD is this length here. Not so. But from the information that we have, okay, we can't calculate BD immediately. Not so. Because we have a triangle looking like this. That is BDA, 90 degrees. That is 2 meters. We don't have no angles. But looking at triangle CAB, we can calculate actually CB. Once we have CB, we can apply Pythagoras to calculate BD. You all understand? Okay. So let's go. So in 2.2.1, since we know that those two lengths are equal, so we're going to calculate those lengths, and we have the inclusive angle. So we can actually use the cos rule. Not so. But the sine rule is going to be easy. I think in the memo I've used the cos rule. Okay? The sine rule is definitely going to be easier here, provided I know the size of that angle here. Remember, this is an isosceles triangle. So those two angles are equal. So we know that ACB is equal to ABC. No reason required because we're busy with trigonometry. Okay? This is the angle I'm interested in. So I'm going to say angle ACB plus this angle B is equal to ACB. Yes, miss?
Chapanka Lolly, is she with you?
No, miss. She's with? No, she's not. I got grade 12s with me, miss.
Okay.
Okay. So, under 10 degrees is equal to 180. So I'm using the fact that this is the sum of triangles. The angles in a triangle. Okay, it's equal to 180. So ACB is equal to?
My apologies for the interruption.
180
Chapanka Lolly, can you come to
minus
the
110
grade 8?
divided by 2. It's going to give you an answer of 35 degrees there. Okay, so now I apply the sine rule. So AB over sine 35 is equal to 9 meters over sine of 110 degrees. So I take it up, becomes AB is equal to 9 So you got 9 times sine 35 divided by sine 110. Your 5,4935. So it's 5,4934 and the number carries on. Yeah? Okay. But that is for AB. So that's going to be 5,4934. Remember, that's a right angle triangle. So I'm going to apply the theorem of Pythagoras here. So BD squared is equal to 5,4934 and the number carries on. Squared plus 2 squared. So BD squared is equal to, the answer squared, plus 2 squared gives you 34,17838 and the number carries on. And I'm going to take the square root thereof. It's 5,84622. So it's 5,846 meters. Okay. Okay. Let Onela go. Who's Peter? The name she was saying now, okay? Yes. You talk in your sleep, I go. Okay. Remember the question says the 4 decimal places. So if you didn't round off to 4 decimal places, of course you're going to lose a mark there. Then the next question says calculate the size of CDB. CDB. Angle CDB. So that angle there. Because one of two ways I can do this. You can either see that the two triangles are congruent. The triangle DAC is congruent to triangle DAB. If you could have seen that, then we know that angle ADB would be the same as CDA or ADC. Okay. So again, you work in a right angle triangle. This is now for 2.2.2. That is 2 meters. That is 5,4934. So I can work out this angle here, which is angle D in this triangle of ADB. So which trigonometric function uses opposite and adjacent? Tan. So I'm going to say tan of ADB is equal to opposite, which is 5,4934 over adjacent. So ADB is equal to arctan. We shift tan of 5.4934 over 2 to 69,99. So it's basically 70 degrees. Not so? So it's 70 degrees. So therefore, CDB is equal to 2 times 70, which is 140 degrees. That's one way of doing it. Otherwise, I could have applied, you see here, there's the triangle. I could have applied the sine rule and the cos rule again. Why? Because I have 9, I have 5,8462, and this is going to be 5,8462. Then I apply the cos rule and I work out the angle since I got 3 sides. Okay? Yes? Sorry? What's he say? The cos rule. But the cos angle, we still must identify that that is a congruent triangle. Okay? So we're going to say 9 squared. If we let it out, it's no problem. I didn't penalize you then. Yeah. It's going to be safer. But again, no reason required. Okay. So you're going to get 5,8462 squared plus 5,8462 squared minus 2 times 5,8462 times 5,8462. I'm going to put the squared. So we are already running out of space here. To 5,8462 squared cos of CDB. So my first aim is to get that on its own. Okay? So it's going to be 9 squared minus, I'm going to say that is 2 times that. So it's 2 times 5,8462 squared equals negative 2 into 5,8462 squared cos of that angle. So I divide both sides by that factor, which is negative 2 times 5,8462 squared okay. So that cos of CDB is equal to 9 squared minus 2 times 5.8462 squared, and that is over negative 2 times 5.8462 squared. Okay? That gives you an answer of negative 0.18497, and the number of course carries on. Okay? So, because this is negative, the angle has to be an obtuse angle. Not so? So you say reference CDB is equal to cos. So shift cos of that negative equivalent. It's going to give you an answer of 80 degrees. But remember, it's an obtuse angle. I made a mistake somewhere. Supposed to have gotten 40 here. Is this, see where's my mistake? Okay, so it's 9 squared minus 5.8462 squared minus 5.8462 squared over negative 2 times 5.8462 squared. Of course. It's 100 degrees. You guys don't pause the video yet, don't let the thing go too long unnecessary. Okay, so at this point I just can't pick up where the mistake is, but because of time I would have to accept this, but I will have a look at it again, and then you can just find in the description box the explanation why the answers are different. It might be that this is not a true triangle, which means to say that the angles doesn't actually add up to what is given here. Okay? That could be the case. Okay? Because if we draw a triangle here and we put 3, 4, 5 here, then this angle can only be one of two angles. Okay? But if I put 40 here, which is not the correct angle, then the triangle is not balanced, in other words. You guys understand it? So I think that is the case here. Okay? The triangle is not balanced. Or for the values that we have here. Or I am doing something wrong in calculation. But because we only have like a few minutes left before the bell rings, I need to finish up. Okay? So at this point I would have to accept this angle to be, if it's 80, then CDB has to be 100 degrees. So for those of you who got 100 and 170, you should get the full 3 marks there. Okay? For now. Sorry about that. And I penalized you for whoever got 100 there. So because more than one person got 100, it might be that the diagram is not balanced. Okay? Once again, sorry about that. Let's carry on. In question 3, we are told that in the diagram alongside A and B are the y and the x intercepts respectively of the line y equals, so this is of the line y equals negative 2x plus 6. Then we are told that A, B and B, C are tangents to the circle at P, which is 2 and 2, and T, which is 5 and 1. The question says, determine the equation of the line passing through P and the center of the circle. People, if there's a line going through P and the center of the circle, then this line has to be perpendicular to that line. So tangent is perpendicular to a radius. Okay? Tangent is perpendicular to the radius there. Then of course, the gradient would then be, if this is negative 2, your gradient has to be a half. So y is equal to half x plus c. We'll substitute p, which is 2 and 2. It's an x and a y. So 2 is equal to a half times 2 plus c. So c works out to be 1. The equation is y is equal to a half x plus. You all agree with that? Initially when I worked out the memo, I used, no, that wasn't the issue. Okay. That's number 1. In 3.1.2, the question says, it is further given that C is the center of the circle. Further given that C is the center of the circle, so there's C. And so now write the equation here, which is y equals half x plus 1. Okay. Show that the coordinates of the center of the circle is 3 and 4 for 4 marks. So when I worked it out initially, there was probably a quicker way that it could have been done. Okay, but when I marked it today, I just couldn't find it. That's why you'll see in the memo that I've written so much in that 3 or 4 lines. Can you see there was very little space for that question. But what I did was, I actually worked out, we know that C is the point of intersection of those 2 lines. That is perpendicular. But if that is perpendicular, then this has to be parallel to that line. So the gradient has to be the same. So the gradient of this line is going to be negative 2. So y is equal to negative 2x plus c. We'll substitute t, which is 5 and 1. So it's going to be 1 is equal to negative 2 times 5 plus c. That's minus 10 is 11. Y is equal to negative 2x plus 11. This is this line. Now, as you know, that C is the point of intersection of those 2 lines. Okay? So therefore, a half x plus 1 has to be equal to negative 2x plus 11. So that over becomes 2.5x is equal to 10. So if I divide 10 by 2.5, indeed I get an answer of 4. To get the corresponding y value, I substitute it into any one of the 2 equations. So it's negative 2 times 4, which is negative 8. Plus 11 is, of course, 3. So that point C is 4 and 3. Okay. The link to the paper and the memo can be found in the description box below. Okay. Let's look at B. B then wants you to calculate or determine the equation of the circle determine the equation. Okay, determine the equation in the form as they told you it's a circle in that form. So we know that your A and your B is going to come from the center, so it's x minus 4 squared plus y minus 3 squared is equal to r squared. Now in order to calculate r, I must substitute the point that's lying on the line. Let's go with p, which is 2 and 2. So you got 2 minus 4 squared plus 2 minus 3 squared is equal to r squared. That is 1 squared and 2 squared, so it gives you r squared to be 5. So the equation is x minus 4 squared plus y minus 3 squared is equal to 1. Okay. Then the question, last question pertaining this graph, or this circle, it says hence calculate the minimum distance from the circle's circumference and the x-axis. Okay, so the minimum distance from the circle's circumference to the x-axis. So if you look at the minimum distance, of course it has to be in line with C. But C is the length. What's the length from center to the circumference? Square root of 5. Can you see that? That was your radius. Anyway from center to circumference is 5. But what is your length from C to the x-axis? 3 units. No, 4 units. That's 3. 3 units. So the minimum distance is that there is what we're looking for. Can you see that? So your minimum distance is definitely going to be 3 minus the square root of 5. If you want, you can leave it like that. You can just work it out. Square minus the square root of 5 gives you an answer of 0.76. 0.76. So any one of the two will give you the full mark. Okay? Let's carry on. In question 3.2, a teacher creates 2 circular areas in a class for toddler A and toddler B. Okay, so we have 2 circles here, toddler A and toddler B. The first area is for toddler A and is modeled by, so let's go with A. It's modeled by an equation x squared plus y squared plus 2x minus 2y plus 1 is equal to 0. We're going to write it in the standard form. So it's x squared, I'm going to complete the square, plus a number, plus y squared minus 2y plus the second number is equal to minus 1 plus the first number plus the second number. The number here in question is 1 squared. 1 squared is 1 and 1. That cancels. Leaves us with 1. It's your perfect square trinomial here. So it's going to be x plus 1 squared plus y minus 1 squared. So the center of circle A is called that coordinate A. It's going to be negative 1 and 1 with a radius 1 of 1. However, the circle B, let's call this A, B has a center of 3 and 4 and a radius of 2. As you can see, that is r squared. Okay? That is your center here is negative 1 and 1. Your radius, of course, is 1. Okay? The teacher claims that the plane areas will never touch or intersect. Is this teacher's claim correct? Support your answer with appropriate calculations. Okay. So we started our calculations already. Okay. So if the distance between point A and point B is larger than the sum of the radii, then the circles never intersect. If the distance between A and B is equal to the sum of the radii, then they will touch each other at one point. And if the center from the center of A, circle A, to the center of circle B, if that length is less than the sum of the radii, they will intersect at 2 points. Okay. So let's look at the distance AB. So we use that thing. So it's negative 1 minus 3 squared plus 1 minus 4 squared. So the length of AB, square root of negative 1 minus 3 squared plus 1 minus 4 squared. That gives you 5. Alright, that's the radius. 1 plus radius 2 is going to be 1 plus 2, which is 3. So we say, since the distance of AB is larger than radius 1 plus radius 2, therefore, the teacher is correct in that way. Okay. The last question. Okay. Question 4. You are given h of x is equal to 3x. Determine the equation in that form. So the first thing is we replace h of x with y. So for the inverse, x is equal to 3 to the y. So y is equal to log x base 3. So that is the inverse function. The next question says 4.2. Can somebody correct the files along? 4.2. If there's a query on your paper, please wait. I need to change it. Okay? The rest of you can add your files. Draw the inverse function. So we draw it normally for the function first. So that is 3, 1 over 3, 1 and 3. So for the inverse function, so well, that's enough to draw the graph. That is 1, 3 and 1. Okay. 4.3, the question says, write down the domain of the inverse function. So the current domain So currently the domain of this graph is, the current domain of the graph is x is greater than 0. But if you look at minus 3 or plus 3, the graph is moving 3 units in that direction. Which means to say x is then more than negative 3, because the asymptote also moves 3 units in that direction. Okay. Let's look at the next question. We are told the graph of h of x, which is 3x, is reflected about the y-axis. So if something is reflected about the y-axis, x becomes negative. Then translated up. So I must add a q value here. It's passing through the point 2 and 4 ninths. That's x and the y. So 4 ninths is equal to 3 to the minus 2 plus q. Q then works out to be 4. The equation y is equal to 3 to the minus x plus 4, or y is equal to a third raised to x plus 4. Okay. And the last question, the bonus question is, solve for x if 199 plus 195 plus 191 plus, it goes all the way to 3 plus 7 is equal to x plus 1 plus 5 plus. People, what you should notice here that we are subtracting 4 here all the time, not so? Here we are adding 4 all the time, not so? However, if I take everything to one side and x on the other side, I would have x is equal to 199 minus 197 is what? 2. Not so. 195 minus 193. 2. 191 minus 189. 2. So that will happen all the way. Now, 3 minus 1 is 2. 7 minus 5 is 2. Can you see that? So we just need to know now how many 2's are there. Okay? So what we do is with our information of number patterns, taking that sequence, we got Tn is equal to A plus n minus 1 times D. And that is and this is your last term, which is equal to 3. So we got n minus 1 times negative 4 is equal to, put on your calculators, 3 minus 199. Lekker geslaap, Stierman? Not yet, okay. Are they still sleeping? What is 3 minus 199? Negative 196. So n minus 1 divided by what now? 196 divided by 4? Sorry? 49. So in other words, there are 52's here, not so? So therefore x is equal to 2 times 50, which is? Okay. People enjoy the rest of your day. Good afternoon, class.